Hello, everyone. My name is Nicola De Tullio, and for the past 6 weeks, I've had the pleasure of working with Rolls Royce Motor Cars on a methodology for the prediction of loyal customers. There are a number of reasons why focusing on loyal customers is important, not just for any business, but I think in particular for Rolls Royce. As you all know, looking for new customers is a very difficult exercise and can sometimes be also very expensive. At the same time, customer relationships and customer intelligence gathered can be used to improve the efficiency of marketing campaigns. Currently, at Rolls-Royce, a loyal customer is worth about 3 times an unloyal customer. However, prior to this project, there was no systematic approach in place for the prediction of loyalty, meaning that Rolls-Royce were potentially missing on millions of pounds of revenue from customers that ended up spending their money elsewhere. When I first met the guys at Rolls-Royce, they had 2 main questions. The first one was, given a group of customers, can we identify a strategy that differentiates between loyal customers and non-loyal customers, and that then can give us an idea of which of the non-loyal customers are the most likely to become loyal? And if we can do that, can we also predict which model are they most likely to buy next? Before I could answer this question, I had to have a look at the data set. For this project, we had access to a data set of European customers, which did not have any personal customer information. Instead, we had to make our predictions using customer experience data, like, for example, how many car service visits they had per month, or how many marketing events they attended per month. Customer behavior data, like, for example, how long ago they bought their first car and how many kilometers they do per month. And also information about the first car they bought, for example, which model they bought and how old was the car when they bought it. With this data, I developed a methodology for loyalty prediction, which essentially takes the group of loyal customers together with a group of non-loyal customers and tries to identify the differences between the two. It then draws a boundary that best separates the 2 groups and flags the non-loyal customers that lie within this boundary as potential new loyal customers, because these are the customers that are closest to the loyal group. With this methodology, we are able to correctly label 80% of the loyal customers and 70% of the non-loyal customers. And now we have a list of potential new loyal customers. Now, having done that, we would like to also try and predict which model they are most likely to buy. We can do this in different ways. Perhaps the simplest way would be to just say, we take the most popular model, and we say all customers will buy the most popular model, which is a phantom. If we do that, we obtain a classification score of about 22% on this scale. It turns out we can do a little better if we just pick a random model for each of our customers. So on average, we get to 26%. What we could do next is to just train a machine learning algorithm, and in particular, a random forest, which takes this up to 54%. So there's clearly a signal in the data that the machine learning algorithm is picking up. If we want to understand what this signal is, we can also do another thing. We can predict that all our customers will buy the same car they bought as their first car, so the same model they bought as their first car. And we realize that among other signals in the data, the random forest is picking up the main trend that we have, that customers tend to buy the same model twice. Now, to conclude, we have developed a methodology that can potentially make millions of pounds of additional revenue for Rolls-Royce. The model will be used by the European region to improve the efficiency of their next marketing campaigns. And the data science approach developed during this project will then be rolled out by Rolls-Royce globally. Thank you very much.